Hey guys, welcome back to the channel. So in today's video we will be talking about we'll be talking about biomolecules. So according to Chem 191, or if you're not a part of Health Science First Year, you can still watch this video and take something out of it. So biomolecules, first lecture we'll be talking about the structure of coenzyme A, the different functional groups, the different reactions in getting it to work the way it is, and I'll show you in just a moment. So first off is like one of the very first slides of biomolecules are what are the functions, why do we have so first of all, you've got four different major types or classes of biomolecules. Those are carbohydrates, proteins, lipids, and nucleic acids. Right, so those are the four main ones, and basically they do the majority of the functions in your cell. So an example would be coenzyme A. So what you don't have to know the entire structure of coenzyme A, but what they want you to know is, what they want you to be able to take out is, you have to be able to identify the different functional groups of coenzyme A. So like, for example, if you look at the molecule, what functional groups can you identify, and what are the functions of each functional group? So basically you've got, let's draw it out. This is what coenzyme, it's a pretty big molecule, and you see why in a moment, but most of them are pretty repetitive, and if you've done A-level chem before or anything of equivalent, so it's a single bond, then you'll be able to tell, or you'll be able to know what this is. Right. So this is a very big hint. Right. So based on the name alone of coenzyme A, you know that coenzyme, it's a protein, okay, but it has an A as well. So what does that A stands for? And you'll be able to tell in just a moment after I finish drawing the structure. But A basically stands for adenosine. Right, so let me finish drawing this out. Right. So this is a very big, again, this is going to take a long time. There we go, we're almost there. And it's true, finally we're done. All right, so this is the entire structure of coenzyme A. So what can you identify based on this? So right away, right off the bat, I can see, okay, this is a thiol. This is an amide. So you've got two amides here. All right. This could also be an ester if you think about it. All right. Or I'll just say this one could be alcohol. Just keep it simple. This is diphosphate or phosphoanhydride, because you've got two phosphate sharing an O in the middle. So here we go. Another one. This one as well. Phosphate ester. And this is your sugar ring. This is your, this is your, this is ribose. It's not deoxyribose, it's ribose, because you still got OH here. And this ring here is adenosine. That's why it's called coenzyme A. This is the nucleobase, obviously, and then this entire thing is just a carbohydrate. So based on that, we need to be able to identify the function of each. So this is thiol, is responsible for building molecules. So building molecules, right? This guy, amides are amides, they don't have a specific function to, according to the science. You don't need to know, you just need to be able to identify that these are amides, but they tell you, they didn't list out the functions of amide. But for like alcohol, this is amide, okay, alcohol, this is phosphate anhydride, or phosphoanhydride, my bad. This is phosphate ester. Right, this is your nucleobase, which is your adenosine. Right, so the alcohol and the phosphoanhydride and the phosphate ester, so these three are responsible for solubility and binding, because they can form, because these guys are polar, you know, they can form hydrogen bondings with other molecules in their surroundings as well. So they're responsible for solubility and binding. For the adenosine and this sugar right here, it's just for recognition, molecular recognition, yeah. So this part, these two parts, is for binding to an enzyme active site. And that is part of molecular recognition. Now, that is the first bit. We'll also talk about the functional groups as well. So obviously, you've got alcohol, so functional groups. You know, and then I've got the structure. Yeah. So for example, I've got alcohol, ROH. I've got amine, it's just RNH2 or whatever, you know, you've got different classes, primary, secondary, and tertiary. Amide, RCOONH2. I've got, let's say aldehyde, RCOOH. Ketone, RCOOR. Carboxylic acid is COOH, and ester is COOR. There you go. So those are the main functional groups, all right? So they dive in pretty deep, not that deep, but they do cover alcohols as well. So it's got different types of reactions. So as you know, the alcohol, it can form hydrogen bonds because of the polarity of the electronegativity of the oxygen atom. And therefore, if the alcohol has a longer side chain or R chain, will be less soluble, but if it's shorter, and it'll be more soluble. It can be, so alcohol, again, you've got different classes of alcohol. You've got primary, secondary, and tertiary. Primary can be oxidized into, primary alcohols can be oxidized into aldehyde, and then the aldehyde can be further oxidized to form a carboxylic acid. And for secondary alcohol, it can be oxidized to form ketones, and that's it. You can't oxidize tertiary alcohols because of the steric hindrance, the three big R groups, and it won't keep further oxidizing. Right? I forgot to add hemiacetal and acetal. Well, those are very important. So hemiacetal and acetal, so it's got RCOHOR. R. That's amiacetyl. RCOR, OR, R. Right. The two OR versus one OR and one OH. There you go. Right. You also need to be able to know that alcohols can react with carboxylic acids to form esters. This is very common knowledge in A levels, right? So we'll talk about redox half equations as well. So specifically, let's talk about aldehydes. The silver mirror test, the Tollens reagent, where you're going from silver. So let's talk about it. Give me a sec. Silver mirror test. You've got Ag plus going to Ag plus E minus. So what you do need is so for example, I've got CHO. So this is your aldehyde. And if I add this guy right here, or from RCOO minus plus H2O plus electrons. There we go. Simple as that. Therefore, I have to double this half equation as well. So this one, yeah, just have to memorize it. But basically, if you react an aldehyde in basic conditions with silver ions, then you will reduce the silver ions to silver metal, which forms that silver color, which is why it's called the silver mirror test. And the molecule itself will be oxidized from an aldehyde into a carboxylic acid, or in some cases, it can be also, it's helped with forming an acetyl group as well. Because again, you've got the two O's, single bond. But yeah, so this is right now. This is the conjugate conjugate base form of the carboxylic acid. Right. You also need to know that in living systems, that coenzyme called NAD+ will oxidize ethanol, the alcohol, into ethanal, the carboxylic acid, and itself will be reduced to form NADH. So this is for all your biology people in A level, so it's very common. Yeah, so the NADH is enzyme or cofactor. And you also need an enzyme as well with this reaction. So it's basically just NAD plus ethanol, so it's CH3, CH3, CH2OH, and then you go into, so you've got an enzyme of ethanol dehydrogenase, right? So again, this is in your A-level biology of rice plants, if you didn't know. They form NADH plus CH3CHO. Right, so something like that, and then I have to balance this equation as well. So I'm missing 2 H's. Yeah. Something like that. Somewhere along the line. Or actually, you just need 1 H plus. You don't even need the electrons. Just 1 H plus must be enough. Yeah, you also need to know that the difference between ether and ester. Ether is just this, and ester is this. There you go. And ether are less reactive than esters because of the quite positive carbon of the COO bond, because the O, of course, is very electronegative and will pull the pair of electrons towards itself, so the bond will be weakened. Okay. Now we'll talk about nitrogen-containing groups. Again, they can be classified into primary, secondary, and tertiary. And you need to know that amides are not very basic or nucleophilic. Amides are this, RCON, something. They're not very nucleophilic or basic because of the lone pair on them will be drawn towards the structure over here and form a basically resonant structure of O, and then you've got an N, and that's just this bond over here, the resonant structure. So basically, essentially, the lone pair is distributed around the electronegative O and the N as well, so kind of form that resonant structure, which is harder to break and won't accept H plus that easily, so not that basic, or won't attack other positively charged stuff. Because for vancomycin, you just have to be able to identify the function groups on them. So which ones are amines, which ones are amides, or whatever the functional groups are. You've got sulfur-containing functional groups, and those are basically, for example, I've got thiol, a very famous example of thiol we've covered here. It literally just thiols this, this can be shown here. So thiol is just RSH, and now I've got sulfide and disulfide. Sulfide is literally just RSR. Di is RSSR. Disulfide bridges are often found in tertiary structures of proteins. So the amino acids form disulfide covalent bonds between different individual, the folding, so the alpha and the beta, alpha helix and the beta sheets, right after the folding, they form disulfide bonds with each other and connect them, which strengthens their bond. But this is just sulfide and disulfides. What happens is you can go from a sulfide, or you can go from a thiol to a disulfide by literally just reacting it with itself in oxidation and reduction kind of manner. So for example, if I go like RSH plus HS, same thing, right? I'm just drawing it out so you guys can kind of visualize what's going on. This is oxidation forward and reduction is backwards. Right, I'll show you in a minute. There you go. RSSR, and the H's can go out. Right, this is what like the very basic equation would look like. And then you also so this reaction can happen if your thiol is oxidized by certain molecules, like for example oxygen, in the presence of oxygen. Phosphorus containing functional groups. Okay, we've basically done with that. Yeah, nothing else a lot. Chirality, you need to know about S and R enantiomers, or positive and R and S enantiomers, or positive and negative, which I'll cover in the next lesson. Quite easy, in fact.